Hi everyone, welcome back to this channel. In this quick video, I'm going to show you a quick setup for basic spectrum analyzer that we have, especially in the time-gated spectrum analysis. This is a more complicated setup. We need an external signal source to work it out. So first of all, as you can see on the screen, I have one EXG vector signal generator at the bottom of the BSA, and I have the trigger set up for both instruments. The trigger out from EXG is connected to the trigger in Spectrum Analyzer. So before we move on, I have to do something. So there's a setup that I need to do on the signal generator before we are able to make it work, especially on the trigger setting. So let's go to pause and we'll go to the over here. Try again. So let's go to pause setup and go to more. So go to route connections and set polarity. So by default, trigger 1 is not connected to anything. So this is how it looks like by default. So we have to route a pulse sync to trigger 1 because I use trigger 1 as the output to Spectrum Analyzer trigger in. So with that done, and I will set the pulse period something bigger instead of 4 microseconds. So I set it to 1 milliseconds and 500 microseconds pulse width. So let's zoom it back. I'll turn this on. And as you can see, so this is the default spectrum analysis interface. And you can see that there's a 1 pulse there. And let's do an auto tune. So auto tune would tune to the highest power in the spectrum. So this looks like a pulse signal because we haven't set other parameter like RBW or number of points. Let's go to bandwidth. Let's set the RBW to something lower, and you can see something like this, more stable. And let's change the span to something lower, about 10 megahertz, or something bigger, a bit bigger. Let's set it to 50 megahertz, and let's change the RBW to something smaller. So this more or less is what we are looking for. Let's change the span to 0 span, and we can't see anything because the center frequency is off. And let's change the center frequency 1 gigahertz because our sweep time is way too big. So let's change the sweep time to something smaller, and let's say to 5 milliseconds. And RBW, let's set it to the highest so that we can let all the harmonics to go through, and then we can see a square wave. Let's change the reference level. So there we go. So before we go into the gated measurements, let's look at how we can stabilize this reading. So we go to trigger. Trigger is under sweep. Trigger free run. We set it to external. So if we have set the trigger in on this spectrum analyzer, which is connected to EXG trigger 1, you get a stable signal like what you're seeing right now. So we are ready to do the gated measurements. Let's go back to the span. So let's go to last span. Alright, doesn't like it. So let's go to 10 meg. So it looks something like that. Okay, now we set it to gated sweep. So it's under this gated sweep. So before that, you see the difference right now. If we are in 0 span, you won't have that selections of gated sweep or sweep setup. So that's the reason why we have to go back to 10 meg span, just to turn on the options. So let's go to gated sweep. So currently you can't see anything. So let's turn it on. Let's turn on the view. So this is what I did previously. So the default, we have some other reading here, but nevertheless, the concept's still the same. So this is where you set the sweep time. It depends on the pulse signal that you're dealing with. So you can actually increase it to multiple pulses in the screen so that you can choose whichever area that you want to pick. So right now, what you're seeing here, let's set it to 5 milliseconds. I'm interested to just measure anything that is off here. So I want to measure this area. So I move my gate. So gate delay is where it started. So you can actually move that to the left or to the right of the signal. So let's move somewhere here, quite close to it, but not exactly at the point because it's still drift by time a bit. Then we set the length. So the length is the width of the gate. So as close as we can. So we're looking about 500 and 600 milliseconds ish. Alright. So external source, again, this is the one that we choose because we have an external trigger into this BSA. So this is our measurements area. So let's turn it off, the gate view, and it will go back to the spectrum mode. So in spectrum mode, this is how it looks like when the pulse is off. So let's say we want to measure when the pulse is on. So let's go to the gate, delay, let's scroll it. Let's change it to the on area. So it's roughly here. And we can switch off the view. And this is how it looks like in spectrum mode when the pulse is on. So this is very useful when you have a signal, not just power signal, any type of digital modulated signal you want to see in the events like the synchronized channel when it start to talk to your base station or any of your device under task. You want to see it in both time domain, you want to synchronize it, and then you want to see how it looks like in spectrum mode. So you can actually use this gated spectrum analysis mode. So hope this helped. I will have another few more setup guide on this basic spectrum analyzer coming through a couple of weeks. So just stay tuned. Thanks for watching.